The solid outermost shell of the Earth is called the lithosphere. This includes the crust and the upper solid part of the mantle. On average, it is 50 kilometers thick beneath the oceans and 70 to 100 kilometers thick under the continents. The continental lithosphere and the oceanic lithosphere also differ in composition. The continental crust floats on the asthenosphere, the viscous upper part of the mantle that lies beneath the lithosphere. The movement of the lithosphere, which can be observed in a great number of places, is the reason behind earthquakes and volcanic activity. These movements do not take place randomly, but along longitudinal belts. Volcanic activity and earthquakes mostly occur at the edge of continents, oceanic island arcs, oceanic trenches, and mid-ocean ridges. These motion processes mark the boundaries of tectonic plates. The lithosphere is not uniform. It is broken up into tectonic plates of different sizes. Today, we know of 7 major tectonic plates and a number of other smaller ones, which all move in relation to each other. The 7 major tectonic plates are the African plate, the Eurasian plate, the North American plate, the South American plate, the Pacific plate, the Indo-Australian plate, and the Antarctic plate. The theory that describes the motion of the lithosphere is called plate tectonics. There are 3 types of tectonic movement: convergence, divergence, and subduction. Mid-ocean ridges represent an example of divergent plate boundaries. As magma, that is molten rock, rises from the asthenosphere and penetrates the oceanic lithosphere, it reaches the surface, where it cools down and solidifies, forming new lithosphere at the edge of the crack. That is how mid-ocean ridges are formed. As it expands, the mass of molten rock pulls the seafloor apart, causing the tectonic plates on either side of the ridge to move away from each other. Thus, the ocean basin grows wider, a process called seafloor spreading. That is how, for example, the Atlantic Ocean has been formed. However, since the surface of the Earth cannot increase continuously, the surface of oceans cannot increase continuously either. The opposite boundary of the oceanic plates approaches another plate. When the 2 tectonic plates collide, one plate moves beneath another. This is called subduction. The subducting plate moves into the asthenosphere, where it is melted and incorporated into the mantle. At subduction zones, volcanoes, fold mountains, and deep-sea trenches occur. Examples of mountain ranges formed as a result of subduction are the Andes and the Himalayas. On rare occasion, 2 adjacent plates slip along a fault, resulting in an earthquake. This is the case with the San Andreas Fault in California. Oceanic lithosphere is formed continuously at mid-ocean ridges and disappears at oceanic trenches. Thus, the size of plates and the location of dry land are continuously changing. Lateral compressive forces acting on plastic rock cause the rock layers to move upwards or downwards and thus to form anticlines and synclines. Sometimes the compressive forces are equal. When this occurs, a symmetrical fold is formed. This is also called a vertical fold. When the compression is stronger on one side, an overturned fold is formed. The axis of overturned folds leans at a small angle from the vertical. When one of the lateral forces is much greater than the other, the angle becomes greater too, and a recumbent fold is formed. When one of the lateral forces is so much greater that the rock layers are broken and one slides over the other, an overthrust fold is formed. These overthrust folds can reach a width of about 100 kilometers. The Alps and the Carpathian Mountains were both formed in folding processes. An earthquake is a short, elastic motion in the Earth's crust. The most common type of earthquake is the tectonic earthquake, caused by the movement of tectonic plates. This occurs along plate boundaries. The strongest earthquakes are triggered by the collision of two tectonic plates. Tectonic earthquakes occur when tension in colliding tectonic plates has accumulated to a point where the resulting stress exceeds the plate's resistance and their ability to deform. The tension is released suddenly, just like when a stick that is bent too far breaks. Then it spreads out in all directions in the form of waves. The point of origin of an earthquake, where permanent deformation occurs, is called the focus or hypocenter. The point on the Earth's surface nearest to the focus is the epicenter. Here the earthquake has the greatest strength and destructive power. The distance between the hypocenter and the epicenter is the focal depth of the earthquake. The energy released in the focus, or hypocenter, spreads in the form of waves. These waves travel through the interior of the Earth and spread out in all directions. They are called body waves. There are two types of body waves, longitudinal and transverse waves. Their names derive from the direction in which the particles move. The speed of longitudinal waves is higher, so they are the first waves to be detected by instruments. That is why they are called P waves, that is, primary waves, while transverse waves are called S waves, that is, secondary waves. Waves traveling along the surface of the Earth are called surface waves. They result from the interference of the P waves with the S waves. Surface waves travel at lower speeds than body waves, but their amplitude is greater. They cause the greatest damage. Several thousand earthquakes occur daily on Earth. Most of them are so weak that they can only be detected by instruments. These instruments, called seismographs, measure and record the ground motion caused by seismic waves during an earthquake. A seismograph consists of a base fixed to the ground, a paper roll rotating on a cylinder attached to the base, and a weighted pen attached to a frame with a spring. The modified Mercalli scale, or MM, classifies earthquakes based on their intensity. This 12-degree scale shows the effects of an earthquake at a given location. The Richter scale is based on instrumental measurements. It indicates the amount of energy released during an earthquake, i.e., the magnitude measured by seismometers. Each unit increase in the Richter scale represents a 32-fold increase in the energy released. Although today we have a thorough knowledge of seismic regions and the nature of earthquakes, it is still impossible to predict the exact time an earthquake will occur or its intensity at a specific location. Therefore, the best way to protect against earthquakes in seismic areas is to build earthquake-resistant buildings. The architectural design of buildings, their reinforcement, the building materials used, and seismic isolation and damping structures are all important in terms of seismic resistance.